This next category is timed. I mean, it's not really timed. I gave you like 100 seconds, which I think should be enough. Or maybe I didn't give 100 seconds. I don't quite know how it works. I tried to make it so that there's enough time, okay? If you need more time and it's not working out for you, just let me know. But it's determine nature of roots from graph. And so before we do this, I want to give you guys some quick notes. Actually, I think they're already in the notes. So let me go here, and let it load very slowly. Conveniently slow. Just love waiting for the internet. Sure, you guys love waiting too. Welcome back to school. Happy first day back. I love how everything goes so smoothly on the first day back. And then we just keep waiting. Okay, there we go. So the nature of the roots, that corresponds to these three sketches of graphs over here. So when you have a parabola, you know, this is a parabola, like a quadratic graph. It's going to be a U-shaped. It can be facing up or facing down, and it can be anywhere on your graph, right? So when you have this U-shaped graph, you're going to count the number of times it touches the x-axis. This one is your x-axis, the horizontal one. So x-axis, x-axis, x-axis. So you want to count the number of times it touches your x-axis. So let's take a look at this first case. Your U can be facing upwards, or in other cases, it could also be like facing downwards. But the point here is that it does not touch your x-axis at all. If it doesn't touch your x-axis, it has two imaginary roots. All right, so it's imaginary roots because it's floating. It doesn't touch your x-axis. Your x-axis is where your roots are. But if it doesn't touch it, then you're only going to have imaginary roots because it doesn't touch. All right, let's take a look at box number 7. So it says 1 real root or 2 equal real roots. So those essentially mean the same thing. It just happens when your parabola touches the x-axis only one time. So it can look like that where it's facing downwards, or I could just draw a parabola like that facing upwards where it touches the x-axis just one time. And so since quadratics are supposed to have 2 roots, you can count it as that same root twice, or you can just say it has 1 root. So when it touches it one time on Delta Math, it is called 2 equal real roots. 2 equal real roots, meaning it's that same root, but it happens twice. And then the last case is if your parabola touches not once, but twice onto the x-axis. And it could look this way, facing downwards as well. It will touch twice onto the x-axis. So if it touches twice, you have 2 real roots, and then I don't remember if Delta Math specifies that they are unequal. Okay, so your parabola can either touch it 0 times, 1 time, or 2 times. And so if it touches it 0 times, that's an imaginary root. If it touches it 1 time, that's a real root, or 1 real root or 2 equal real roots. And then if it touches twice, it's 2 real roots, unequal. Okay, any questions? So let me clear this screen. And let's go back to Delta Math over here, and let's do 7 problems together. I know 7's a lot more than usual for the amount of examples, but I just want to show you. Okay, so it looks like I didn't time it, so that's what I intended for. So what is the nature of the roots? Notice how it touches 2 times, so we have real unequal roots. Because here's 1 root, like maybe it's a -10 or something. This one's like a -1. They're unequal. They're different points. It touches twice, so you get 2 real unequal roots. This one is floating. So remember, floating means it doesn't touch here at all. So you get imaginary roots. So imaginary is where it doesn't touch at all. It doesn't matter that it touched the y-axis. We don't care about the y-axis. We only care about the x-axis. So this is imaginary. This one, look, it touches 1 time and 1 time only. So you got 2 real equal roots. equal because it just touches one time. Like normally parabolas would touch it twice, but then since it only touches it one time, those two things that it's supposed to touch, they're equal to each other. So that's why you only see it as one intersection. So real equal roots. This one, it's upside down, but that's okay. It touches it twice. So this is real unequal roots because this root is not equal to this one. They're literally different numbers. They're different spots. So it's real and unequal. This one is floating. It's upside down, but it's still floating. Like it's not touching your x-axis at all. Therefore, it has to be imaginary. This one is touching it just one time. And so even though it touches the y-axis, we don't care about that. We only care about the x-axis. We do not care about the y-axis. We only care about the x-axis. It touches it once, therefore you have real equal roots. And this one touches it once. We have real equal roots again. Be careful because the buttons switch places sometimes. Like earlier, real equal was here. Now real equal is in the middle instead of on the right. So don't just click assuming you know where the buttons are. The buttons will switch order. All right, so now that I got 7 out of 7, I can stop. I don't have to keep going. I mean, I could get real equal roots again, and I got 8 out of 7, but that doesn't really do anything. So once you get 7, you can click stop. And I also think if you get it wrong, it automatically stops you. So just be extra careful. You need to get 7 right in a row. Like this one's supposed to have real equal, but let's say I click imaginary, it stops me automatically. So you have to be careful, like be really careful that you don't get one wrong. You have to get 7 correct in a row, and I couldn't change that. So I'm sorry, I tried, but yeah. Any questions on this category? Okay, let's go to the next category.